This is section 10.2, factoring using the distributive property. Okay, so factoring, is the product, the product, and you need to find the factors. Okay, so this is kind of reverse of what we did last chapter. So last chapter, basically we had things separated out in parentheses groups, and then we did our multiplying to make them kind of one thing. Now what they're going to do is they're going to kind of give us what we had for our answers last chapter, and we have to take that and pull things out of it to make it in factored form. So today's stuff is basically going to be reverse distributive property, or the distributive property backwards. Okay, so what they're going to do is they're going to give us something like this. So 24y plus 18y squared. So I'm going to do something similar to what I was doing on yesterday's assignment, or whenever you did the last assignment, 10.1, where we had 24y and the 18y squared, and we broke those into things that make those up. So like we take 24 and break that down using a factor tree. So 24 could say go to like 4 and 6. 4 would go into 2 and 2. Those are both prime. 6 can go into 2 and 3. Those are both prime. Now we're down to all primes there. Then we would take 18 and break that down. So 18 could go like 2 and 9. And then 9 could go 3 and 3. 2's prime. 3 and 3 are prime. Okay? So then we write these in their expanded out form. So like 24 would be 2 times 2 times, there's 3 of them there, and then times 3, and then our y, there's just one of them, so times y. 18, same thing, could go 2 and 3 and 3, and then we've got y squared, so that would be y and y. Okay, so that's what we did in the assignment from the last section. Now, we start doing stuff that's slightly different here. So what we do first is, again, just like last assignment, we see what's the same in both groups. So like here, we got a 2 and a 2 in both groups. I see we got a y and a y in both groups. And it looks like we got a 3 and a 3 in both groups. Then this one's got a couple 2's. We don't have any 2's down there. 3 and a y, nothing up there that matches that. Okay, so what we do with that number then, the 2, the 3, and the y that we have that's in both groups, is that number is going to go out front. So if we take 2 times 3 times y, 2 and 3 is 6 times y, would give us 6y. That's going to be the number that we can pull out of everything or divide all of those numbers by. Then we'll have our parentheses here, and inside of those parentheses is whatever's left. So like for 24y, the things that are left are the 2 and the 2. And then for the 18y squared, the things that are left are a 3 and a y. So now the difference comes in here. I pulled that number 6y out from all of those. So now what's left for the 24y is 2 times 2, which would be 4. And then what's left for the 18y squared would be 3y, and I just put a plus in there because it was plus in between here. And then my numbers, where everything's going, so the 2 and 2, the yellow there, made that 4. The blue made the 3y, and then the green is what we pulled out of both of those, the 6y that went out front. Okay, so now how you can kind of check this here is you can actually do the distributive property. So if we do distributive property here like that times that, that would be 6y times 4 would be 24y, 6y times 3y would be 18y squared. And if you look there, that's identical to what we started with. So you can see how we basically pulled something out of both of those groups. That number goes out front, and then whatever's left goes inside our parentheses there. And then if we do distributive property, we should start with, or we should end with what we started with. Okay? It can be kind of tricky, so that's why I like to break down all those steps like that. Once you do more of these, it won't be as bad. Okay, so same thing we're going to do with the 18FG, and then I'm going to think of this like a negative 21GH squared. You could think of it as subtract or negative. It doesn't really matter either way as long as you include it. So 18 I'm going to break down again. It'll be the same as up here. So I went like 2 and 9. 2's prime. 9 goes into 3 and 3. So that's that one there. And then 21 will go into 3 and 7. Those are both prime, and then I just have to remember to add my negative in with that as well. Okay, so if I write these out then, 18 FG would be equal to, 18 was 2 times 3 times 3, and then FG would be just times F times G. So that takes care of that one. And then 21, which is actually negative 21 GH squared. 21 broke into the 3 and 7, and I also have to remember, since it's negative there, I want to pull a negative 1 out front. So negative 1 times the 3 times the 7, and then I break down my G and my H squared, so times G times H for the H squared. Then I do the same thing I did before, so I see which things are in both groups. So like here, in both groups, I would have a 3 and a 3. I would have a G and a G, and I think that might be it. I think it's just a 3 and a G I can pull out. So then I do that. I pull my 3G out front, and those guys are gone. So in my parentheses is whatever's left. So like if I look at the 18 there, the things that would be left would be the 2, the 3, and the F. So if I take 2 times 3 times F, 2 and 3 is 6, times F would be 6F. And then you can either go plus here or minus, because we're going to have a negative that we pull out of this. So like here, we're going to pull a negative 1, 7, and then 2 H's there. So you could either think of it as like subtract the 7H squared or plus a negative 7H squared. Either way is fine. So I'm going to go negative 7 and then H squared. So that would be my blue, this would be my yellow, and this would be my green. And then if I wanted to check it using distributive property, I could go through there, and I should get the same thing I started with. Alright, one more here. This one, actually 2 more here. So this one, we actually have 3 things to factor. Okay, so just an extra one to do here, but nice, because 5 is actually prime. So when we break down 5a, it's just 5 times a. Then we'll break our 20 down. So 20 could go into 2 and 10. 2's prime. 10 can go into 2 and 5. Those guys. And then 10 can break down into 2 and 5. 2 and 5 are both prime. So then when I do 20 AB, 20 goes into 2, 2, and 5. So times 2, times 2, times 5. Then I got the A times the B, so times A times B. And then I got 10A squared, so 10A squared. 10 broke into my 2 times my 5, so 2 and 5. And then A squared would be A times A. Alright, so pulling things out of all of them, looks like I've got a 5 in all of them, so I can pull that out. Pull out 5. Looks like I've also got an A in all of them. Pull that out. And then I don't have anything left in that top row there, so there's nothing else I can pull out. So even though these both have 2's, I can't pull a 2 out because there's not a 2 in the top one. So I'm going to pull that out front. So the 5A goes out front. We got our parentheses here. And then we want to see what's left. So it looks like there's nothing left in that top row, so we'll deal with that in a second. In the second row here, we got 2 and 2 and B. And then in the last one, we've got 2 and we've got A. Okay, so let's try to figure out here what we need to do with this 5a. Since we pulled a 5a out and there's nothing left there, a lot of times people think that you need to put 0 down here. But if I do that, if I put a 0 there, when I go to do my distributing to kind of check here, 5a times 0 is 0, and that doesn't give us back to my original 5a here. So I can't do a 0 there, but that's what a lot of people think, because they're like, well, there's nothing left. Well, there's not, but that doesn't mean we need to put a 0 there, because 5a times 0 isn't going to get us back if we did a distributed property to check. What we actually put here is a 1, because if you think about it, 5a times 1 will get us back to that same 5a that we started with. Okay, so anytime everything pulls out and you're left with nothing that's not being pulled out, you put a 1 there as kind of like a placeholder. And then, so 1 goes with the 5a, and then the next row there, we're left with 2 and 2 and b, so 2 and 2 is 4, so plus 4, and then the b with that. And then the last row there, we're left with a 2 and an a, so that would be 2a. And then if you use your distributed property to check, that would be 5a plus 20ab plus 10a squared, which checks out with the first row. Alright, next one here, we've got 17de minus 15f. So I'm going to change that minus 15 to plus negative 15, go from there. 17 is prime, so I can't really do a factor tree with that, so I'm just going to go 17 de is equal to 17 times d times e, and then negative 15. 15 can break down, so 15 could go into 3 and 5. Both of those are prime, so negative 15f could break into, got to include that negative there, so negative 1 times 3 times 5, and then it's just an f there, so times f. Alright, so now I want to see what's the same in both groups. So I got 17 there, DE, none of those things in the bottom row. So this one doesn't have anything that I can pull out of any of those. So what we put here is either cannot be factored, or you could also put prime. Either one of those would be acceptable. So if you can't pull anything out of those and it's all just, you know, basically simplified enough, you put cannot be factored, or you could also write prime. Okay, so let's flip our page here and we're going to try some. So on page 430, try out A through D, and then I will get you your answers here. So for A, they got 4n out front, and then in the parentheses, 3n minus 2. That could also be plus a negative 2. For B, they got 2ab, and then in parentheses, 8a plus 5b. For C, they got 5rs out front, and then inside 4s minus or plus a negative, 3r plus 1. And then for D, they got cannot be factored, or prime would be fine for that as well. So cannot be factored or prime for that last one. Alright, next thing here, we're going to do some division. So division is really, really similar to what we were just doing because we're pulling something out of all of the things that we've got. The only difference is we don't have to come up with the number that we're pulling out front. Like here we had to come up with the 4n and the 2ab that we were pulling out of those. Here they actually tell us what we need to pull out of those. Whether it's the greatest common factor or not, they just tell us a certain number we want to divide all of those or pull out of all of those. So here we want to divide the group 24a squared minus 20a divided by 4a. So how I would write this out here is I'd go 24a squared minus 20a, and then I'd do like a division bar like that, and then I'd put 4a on the bottom. then from here, what I would probably do is I would break this into two different chunks. I would do one of them as the 24a squared divided by 4, and then the other one the negative 20a divided by 4a. So this would be 24a squared divided by 4a, and then you could either do minus or plus a negative. Either way, negative 20a over 4a. Alright, so then what we do here is we just do division. So like here, if I'm looking at the 24a squared divided by 4a, I know if I take 24 and divide it by 4, I get 6. And then if I take a squared and divide it by a, we remember with division, we're subtracting the powers. So if it's an a by itself, this would be like a to the power of 2 minus 1. And I know 2 minus 1 is 1. So that would be like 6a. And then here I got plus and negative. Again, I would take the 20 and divide it by 4, which would be 5. And then there, both are powers of 1, so it would be like a to the power of 1 minus 1. So it would be plus a negative 5, and then 1 minus 1 is 0. So you could put a to the 0, but we know anything to the power of 0 is actually a 1. So that is the same as 1. And I know if I take a negative 5 times 1, that's just a negative 5. So my answer here would be 6a, either minus 5 or plus a negative 5. Either way would be fine. Alright, on page 430, try out E through F, and I'll get you the answers. So for E, they got 3b squared minus 5. And then for F, they got 2xy plus 1. Alright, now let's do a story problem here. I pulled this one from the book, and I should have typed out more stuff here for the directions, but I'll kind of talk you through what's going on here. So basically we're supposed to come up with an expression in factored form that represents the area of the walkway. Alright, so what our directions are here, and I should have typed these out, but basically we've got a pool here, so this, colored in here, this is our pool, and we are putting in a cement walkway around that pool, and we have to figure out what the factored area of that is. Our pool is twice as long as it is wide. So our pool is twice as long as it is wide, and then we also know we want a 2 meter wide walkway. Okay, so our pool is twice as long as it is wide, and we want a 2 meter walkway. Okay, so a lot going on here. First thing I would think is, okay, so my pool here, the blue, is twice as long as it is wide. Well, say it's x wide. If I want that to be twice as long would be like 2 times whatever that is, so it would be like 2x. Okay? Now I also have to think here, I need to have a 2 meter wide walkway. So I would think, okay, from there across to there has got to be 2 meters. Okay? That would also apply to like there to there, there to there, there and there, all the way around there. All of those distances are all going to be 2 meters. So what I'm going to have to think here is I'm going to have to think, okay, I need to figure out my area of, if I think about this like as 2 rectangles, I need to figure out the area of my bigger rectangle there, and then I need to subtract away my area of the pool, or the smaller rectangle. Make that one blue so you can tell that's the pool. So if I figure out the area of the big rectangle there and then subtract away the pool, that'll give me what's left for the walkway. Because I don't want to order too much cement, because I don't want to spend a bunch of money on cement that I don't need to fill in that pool. I just want it around the edge. So what I'm going to do is I'm going to take my dimensions here that I know, and I'm going to put these up on the edge. So I know my walkway from there to there is 2 meters. I know my pool length from there to there is 2x. And then again, my walkway over here is the same distance. So that's also going to be a 2. Then I'm going to figure out my dimensions going this way. So again, that walkway, 2 all the way around, so it's 2 there. My width of my pool here is going to be x, and then again my walkway there is going to be 2. Okay, so now what I need to think is, if I've got all these numbers along the edge here, what am I doing with those? Well, I'm going to take those measurements and I'm going to add them together. So it would be like 2 plus 2x plus the 2 there to get the total distance along the side there. Same would work here. It would be pluses in between there. So if I think about my length or my width of this whole thing here, I've got 2 plus x plus 2, so the 2 and 2 can go together, so my total distance there would be x plus 4. Here, same situation, I got 2 and 2 that can go together, plus my 2x, so my whole distance there would be, I'm going to go into my words here, but it would be 2x plus 4. And that would be basically my dimensions of my big rectangle. So x plus 4, and then 2x plus 4 for the dimensions there. Then for my pool, my dimensions are already laid out for me. I've got x by 2x. So x there, 2x there. So then what I would probably do is I would multiply these because I need to find area. So I would take my dimensions there, so x plus 4 times 2x plus 4. And then here I'm going to subtract away the pool, so minus, and then my dimensions there would be x by 2x. Alright, so let's do some foiling here. So if I'm doing FOIL, it would be first and first would be, drawing very good there, first and first would be x times the 2x, which would be 2x squared. Outside would be x times the 4, which would be 4x. Inside would be 4 times the 2x, which would be 8x. And then last would be 4 times the 4, which would be 16. So plus 16. And then while I'm at it, I might as well do this one out here. So it would be minus, and then x times 2x would be 2x squared. Then I'm going to want to take and see if there's anything that I can combine here, which if I look, I can combine the 2x squared and the minus 2x squared. So if I've got 2, x squared minus 2x squared, that's actually going to cancel out, right? So those are going to go away. Then I could combine my 4x and my 8x and make 12x, and then drop down my plus 16. So now part of the directions were write an expression, which we did, but we need to factor it, which kind of stinks because we did all that work and we're still not done. But now they want us to factor this, which actually isn't too terrible, because if we're thinking, okay, the greatest common factor of 12 and 16 can't be 8 because 12 doesn't divide by 8, can't be 6 because 16 doesn't divide by 6, so it's got to be 4. So my greatest common factor of both of those numbers would be 4. If I pull a 4 out of 12, I'm left with 3. Then I've also got my x there. If I pull a 4 out of 16, I'm left with 4. And then I can always double check myself and go, okay, is there anything I can pull out of both the 3 and the 4? Well, there's not, so I know that that's factored all the way out. So after all that work, that's my answer. Okay, that is it for your notes. So your book page assignment that goes with this is page 432, 20 to 46 even.